Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby. So I'm excited to be talking to Eric Wallace, who works at Stephen Winter Associates, providing consulting, design, and inspection services for solar energy systems. He actually also gets involved in a variety of programs, including Energy Star, Enterprise Green Communities, and New York City Energy Code projects. But before joining SWA, Eric spent several years designing commercial-scale solar power systems, large and small commercial scale, as well as some single-family and multifamily and institutional projects. Today, we're going to focus on solar photovoltaic systems. We're going to talk about urban installations and specifically New York City regulations. So I'm just going to jump into the conversation that we have with him. So welcome, Eric. Thanks for being on the podcast.
Thank you very much, Kelly.
So I just want to kind of dive right in. Can you kind of lay the groundwork for us? What does the solar market look like right now, and kind of what's your component of it?
Sure. So the big story of the solar market over the past decade is really about cost reduction and sustained incentives. So looking just since 2010, residential and commercial scale systems have dropped about 60% in cost. Utility scale systems have dropped almost 80% in cost. What remains to be the highest cost barrier for solar are what we would call soft costs. So those are your engineering, your sales acquisition costs.
You basically.
Yeah, me. Or any permitting costs. So anything other than like the material and labor costs, just the material cost of the system. So that has dropped hugely in countries like Germany and Australia, but it remains high for a variety of reasons in the United States. But despite that, there's been huge drops in cost. On top of that, we still have great incentives. The federal investment tax credit is worth 30% of the cost of the system right now. That's scheduled to kind of sunset over the next few years. But the good news is that it survived the most recent revamp of the tax plan under this administration, which is kind of proves the general knowledge that climate change might be controversial, but solar power isn't. It has support kind of bipartisan across the board, mainly because it's saving people money and giving people more choice on power.
That sounds great.
Yeah. Other than that, you also have new tariffs in the past year or two, both on modules and cells, as well as on steel and aluminum. And the exact impact is yet to be seen. There's some estimates around 10 to 14 cents per kilowatt for installation increase in cost, but they are reviewing exemptions to the rules, and there's bound to be legal challenges to these tariffs, so it's still not really clear what the overall impact is going to be.
Okay, great. And you mentioned incentives, and a lot of them are tax related. Have you run into any issues with clients that you've worked with that have problems taking advantage of the tax incentives? Yeah,
the biggest issue is usually if we're working with a nonprofit developer, for example, with a low-income housing development. Sometimes they can find ways to get around that if they can get like an equity investor or have, say, maybe a for-profit branch of their organization that can take advantage of the tax incentives. So there are ways around that. There are also certain companies that specialize specifically in providing what we call a power purchase agreement to nonprofit entities that can't take advantage of those incentives. So if a nonprofit developer is trying to build a low-income multifamily building, but they can't get those incentives, they can go through a company like Grid Alternatives that specializes in providing that for them.
Okay, great. And can you talk to me a little bit about the type of solar and specifically solar PV photovoltaic systems? What's common? I know, years ago we heard about building integrated PV. We heard about different chemistry, cadmium telluride. Discuss a little bit about what's happened with the specific types and where we're at now.
Sure. So there are a variety of different technologies available. The vastly most common and cheapest is the crystalline silicon module, kind of your standard regular module. There were waves and pushes for things like concentrated photovoltaics, thin film modules, built-in PV, but a lot of those really didn't survive, or they're still around, but they didn't win the race because regular crystalline PV just dropped in price so rapidly. And when you're talking about installation methods, this can be the same for multiple technologies, but you essentially have a ballasted option where your PV modules are weighted down by concrete blocks and they have a pretty bare bones, lightweight tray or small racking system that lays pretty low profile on the roof. Those are going to be your lightest, cheapest, definitely the most common. And you can also do something like a light gauge steel rack on top of your roof. If you want to get some extra tilt, some extra height, if you can combine more modules into a tighter space when you do that sort of racking system.
Okay. About ballpark, what would be the sort of the percentage increase if you went to that type of system?
It's a little less than 50%, up to maybe 50%. So a ballasted system using kind of really high-end modules is going to be about 14 watts per square foot. That's primarily because the way your ballasted system works, the rows of modules are all tilted individually. And so you need space between the rows so one row doesn't shade the other one. Mm-hmm. When you go to a rack, your modules are all just butted up right against one another and they're on a continuous tilt. So your watts per square feet is going to go up to something more like 18 to 20 watts per square feet.
Gotcha. Okay, yeah. Great. And I've talk to me a little bit about how you optimize for a typical building, kind of thinking in an urban environment. How do you optimize that type of building for installing solar?
Sure. So there's a lot of obstacles to putting solar in an urban environment. You have plenty of sources of shade. Tall buildings can lead to some pretty difficult engineering issues. You have a high demand for square footage and space on the roof. So the big thing is the bulkheads. Are they shading the area where you want to put your modules? How much space is the bulkhead taking up? And any mechanical equipment, or if you want the roof to be accessible to your tenants. So the main things for optimization from those points of view are put your bulkheads and any equipment that has to be on the roof, RTU or your ERV, as far to the north as possible. Obviously, sometimes the geometry of the building kind of limits what you can do with your bulkhead, but as much as that is possible, you should do that. If you can unitize as much as your HVAC equipment as possible to get it off the roof and free up space for the PV, that's great. And if you can't get around these things, or you're limited on how much you can move stuff, creating a kind of uniform open area for the array and not putting your fans in kind of odd configurations, that is really good because it's nice to have a very regular large area for your array. If you want to maintain the space as an amenity space, another installation option is something more like a more structural steel support for your PV system, like a trellis or a big canopy above the roof. That's going to add some significant cost and structural requirements for your building. But then you maintain that space underneath, and you can also get up above the shading from your bulkhead often.
Okay. And what about, do you know kind of approximately how much more are those types of systems costing to kind of maintain that space below?
Yeah, it's usually going to be like $1 to $1.50 more per watt, which is fairly significant when for a ballasted system in New York City, in that urban environment, we're looking at about $3.50 per watt.
Okay, yeah.
For this canopy trellis type system, you're looking at more like $4.50, maybe $5 per watt. A light gauge steel rack, more like $4 per watt. And these are all pretty high markup compared to elsewhere in the country. So whereas $3.50 per watt in New York, you're going to see a ballasted system in a big commercial project can be closer to $2 per watt somewhere else.
Okay, wow. And then for this ballasted system, could you use that to be over mechanical equipment, or is there any drawback to that?
So the ballasted equipment is very low lying to roof. It's not going to go over anything. It has to even go around your roof drains. You don't want to block the water being able to get to those. So you can maybe get over mechanical equipment with a light gauge steel rack. You run into issues about access. So you want to maintain, a 3-foot path to your different fans in case you ever need to service them. So the issue with that is that even if you can get your light gauge steel rack above, because of the strength of that steel, you're going to have a lot of bracing, and that might prevent you from being able to get into that fan. The other question is it equipment that is exhausting heat? So heat is going to reduce the efficiency of the performance of your modules. So that should also be taken into account if you're spanning over any HVAC equipment.
Okay, great. That's interesting. Can you, switching topics a little bit here, but let's talk, kind of go into the net metering. How is that structure now? Are there any drawbacks to kind of our current typical, actually first explain net metering maybe.
Yeah, no
We'll
problem.
take it from there.
So net metering is kind of the original blunt tool for providing a revenue stream or a reason why you would want to put PV on your building. Basically, if solar is being produced on your property and you're using it at the same time, there's no difference. It's just flowing from your panels to your load. But if it's being produced in the middle of the day, say on your home, and you're at work, your home is not using any electricity, and the PV's cranking out kilowatt hours, it goes back onto the grid, and then that rolls back your meter. That credits your count in a volumetric method. So basically, you get credit in kilowatt hours for every kilowatt hour you put back onto the grid. Now, that's a great tool just for for promoting solar, and it's worked really, really well, but it's very blunt. And so it actually disincentivizes putting any other types of technologies like energy storage, batteries into your system, mainly because the grid is acting as your battery. And then also it doesn't really promote strategic deployment of things like solar or batteries. It's just kind of, you can connect and you can put it back onto the grid, but there's no difference in how your energy is valued based on location or time.
Okay.
So what New York is doing is replacing that with what they're calling the value of distributed energy resources. It's part of their whole statewide Renewing the Energy Vision initiative. And basically that breaks down any energy that you export into a number of different components. So there is an energy component, basically the hourly wholesale value of electricity at the moment that you're exporting.
Okay.
There's a capacity component, which is set monthly. It's the same as the demand charges that a commercial building would pay. There's a locational bonus if you're in a really dense area. There's a value for essentially the greenness of the power, like the renewable energy credit. So you get an environmental value is what they call it.
Okay.
And then if you include storage, you get a demand reduction value, basically trying to assign an incentive to put storage in because it helps the utility defer any upgrades to their distribution grid. So you add all these together and that gets you your new export value. Any energy you use immediately is essentially still worth your retail rate because it never goes through your meter. But any energy that is exported to the grid gets measured and valued at your new rate. And kind of in some sample calculations, it's anywhere from half to 2/3 the value. So it's definitely less. And so it's kind of a compromise between solar installers and people who want to put solar in and the utilities who are losing money on lost revenue, or independent power producers who are losing money on people, producing their own energy and using the grid just as a service.
Yeah.
So,
which is an interesting piece, right? Because the utilities are actually sort of required to fund different energy efficiency opportunities in some cases. So they have this sort of struggle, I suppose.
Yeah, it's a give and a take for sure. But so if the value now of the power that's produced on site by your solar system is entirely dependent on what percentage of your overall usage are you actually covering, and then how closely does it match your load profile. So if you're only producing a tiny percentage of what you actually use, you're probably never exporting, and so the value of the energy you generate is still the same as it was before. As you increase towards 100%, you need to match your own load profile more and more to get closer to the traditional type of net metering, to your actual retail rate. So this kind of incentivizes putting storage in indirectly as well. So you're going to want to increase your self-consumption of PV, which battery storage can help with. Or if you know you have to export, like you're going to produce more in this week than you can possibly use, it encourages you to export at the peak times on your grid. So let's say in your region of Con Ed, your peak usage is at 7 to 11 or something like that. It encourages you now to put it out onto the grid, which then helps Con Ed deal with congestion on their grid at that time.
Great, yeah, and Con Ed being the utility in New York.
Yes, Consolidated Edison.
And that's That's interesting. And I think I've heard of this, some issues in other locations that maybe haven't incentivized as storage. I think it's referred to as duck curve. Can you talk a little bit about that?
Yeah, so New York is kind of looking forward to that issue. They're not really there yet. They don't have enough solar. But the duck curve is what happens potentially when you have a really high penetration of solar on your grid. So California and Hawaii are dealing with this right now. Essentially, the issue is in the summertime when your grid peak usage is in the later afternoon when AC is cranking up at home, people are starting to come home and use their TVs, turn lights on. But solar is coming offline because the peak solar is going to be in the middle of the day. So as solar is coming offline and load is going up, you're not only turning other generators on to compensate for the loss of the solar, you're also turning generators on to meet that new excessive load. So the ramp up in the afternoon is just huge. And the kind of the shape that you see, it's a small peak in the morning, a big dip when the solar is cranking, and then this huge spike and a massive ramp. And the main way that they're dealing with that is turning on gas peaker plants. Okay. So you're using this less efficient method of burning gas compared to a combined cycle gas plant to meet this huge ramp and load that you have. And you're losing some of the benefits of putting all the solar on the grid in the first place. So the idea is if you can put more storage on the grid, you can soften that difference between the solar peak and the grid peak, transfer some of that load over and help the grid that way. So New York is trying to create a kind of early market-based approach to incentivize more distributed storage on their grid. California's approach is a little more like asking their large utilities to put more, or telling their large utilities that they have to put storage on the grid.
Okay, great. And is anybody else sort of pioneering this distributed storage solution outside of New York?
So New Jersey and Massachusetts are, I don't know the specifics of their policy, but they're putting in some aggressive storage components under their energy policy. Beyond that, it's still fairly new. I think California and the states we've talked about are really the front runners. Okay,
interesting. And the other kind of buzzword I've been hearing, or buzz phrase, I suppose, I've been hearing a little bit about is community solar. What are your thoughts?
So from a technical standpoint, community solar isn't really any different than any other small commercial or large commercial, I should say, PV system. Okay. It's really just an innovative ownership structure. So the idea is that there's a lot of people that have obstacles to being able to participate in the solar revolution. If you don't own your place and you can't put solar on your roof, maybe you do own your place, but you live in a condo or a co-op and you can't just put solar on the roof. There's not enough roof space to go around for all the people that live in your building. If you don't have a good roof, if you don't have access to the money that it costs to install the system or the credit to do a long-term lease, for any number of reasons, there's an obstacle that prevents you from going solar. Community solar basically allows people to pool their resources and purchase solar from a centralized location in their community. By community, I mean has to be in their utility region and in their grid operator region. So if you live in New York City, it has to be in the 5 boroughs, wherever you buy it. If you live in Westchester County, it would have to be up there. Even though they're both Con Ed, you have to be in your own region as well. So basically, it's an innovative ownership structure to get around the obstacles that we talked about. And it expands the market to more people, lets more people go solar, and overcome all these issues. And that's about it.
Sounds great. Great. And so if I invite you back on this podcast in 5 years, what are we going to be talking about then?
If you invite me back on, I'd say, number one, how was the market affected by the ramp down of the ITC? Okay. How did cost...
An ITC?
That is the investment tax credit.
Great.
So there's a sunset clause. It's scheduled to kind of fall off by 2023.
Okay.
How is that affecting everything? Number two, what sort of progress has been made on energy storage? How has the cost come down on that? Number three, I would say, how have California and Hawaii and other states dealt with the duck curve issue? Can they get to really high penetrations of solar? And number four was VETR, the value of Distributed Energy Resources, the New York program. Was that successful? Is everybody happy still? Are utilities and everyone happy? And then lastly, what's happening with community solar?
Great.
Yeah. Has it been as great as everyone thought it was going to be? The potential looks really huge, and it can expand the market, and we'll see if that is actually achieved.
Well, it sounds like we have our agenda cut out for us.
Yes.
Thank you so much for being on.
Thank you so much.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.